Bismillah ar-Rahman ar-Rahim. We'll start now with Newton's method. It's section 3.8. What is Newton's method? Newton's method is just a method to approximate the zeros of a function. You have a function, you want to find what are the c's such that f of c equals 0. Approximation, as an approximation, where f is differentiable containing c, non-open interval containing c. What are the steps? First, I need to make an initial estimate. I need to start with with some value, x1, which is close to c. Sometimes we'll use the graph to help us. Then I will use this iterative expression. What I will do, I have x1, I find x2. x2 will be x1 minus f of x1 over f prime of x1. We get x2. We'll see, is it a good approximation, or we can get x3. I plug x2 in the formula. And so on. So it's like an iterative method. When I will stop, assume I want a desired accuracy, I will check the difference between xn and xn plus 1, like x2 and x3. Is it the accuracy I'm looking for? If yes, then I will stop. By the way, they call this is putting x2, they call it iterations. They call it iterations. x1, I get x2, then x2, I get an x3, and so on. Examples. Calculate 3 iterations of this function. By the way, I know the value of this function, the zero of this function. It's a square root 2, plus or minus square root of 2. But I'm looking for the positive one, which is 1.4 something like this. Yeah, this is square root of 2. Yeah, I put it here. Okay, so this is x1. What I will do, I'll find x2. Now this is f. I need to approximate a zero of this f. So I'll find f prime, because I need f prime in the formula. So I say x2 will be x1 minus f of x1 over f prime of x1. That will be what? x1 is 1. F of x1, plug x1 here, 1 minus 2, that will be minus 1. Plug x1 here, I have 2. So that will be 1 plus half, which is 3 over 2, which is 1.5. I start with 1. Now I'm coming nearby to this 1.4. x3. He said 3 iterations. So this is the first one. x3. I get x2 minus f of x2 over f prime of x2. Very clear, I need a calculator to do that. And if we do the calculation, we are getting this. I put the values. 1.416667. x4. I'll put x3 minus f of x3 over f prime of x3. And if we do the calculation, you get what? 1.414216. If you notice, it's almost there as the correct answer. So with only 3 iterations, I get square root of 2 easily using this Newton's method. So this shows how powerful is this method. Yeah, let us do this question where I can do the calculation without calculator, because in the exam, well, for sure, calculators are not allowed. So we need to consider this. Use Newton's method to find x3 for this function. So this is my f. This is what I want to get the zero of, this fx. So I'll find f prime. What will be? So let me write f of x is x cubed minus x squared minus 1. F prime of x is 3x squared minus 2x. Okay, I'm starting with this, x1 equal 1. I'm starting with x1 equal 1. x1 equal 1. So it will be x2. x2 will be x1 minus f of x1 over f prime of x1. What is x1? 1 minus f of x1. Substitute 1 here. That will be 1 minus 1, minus 1. So that is minus 1 over f prime at 1, 3 minus 2, that is 1. So I have what? 2. Now x3 will be x2 minus f of x2 over f prime of x2. What will be x2? 2, f of 2. F of 2, 8 minus 4 minus 1. So it will be 8 minus 5, which is 3, over f prime of 2, x2, which is 2. 3 times 4, 12, minus 4, that will be 8. So this is 16 over 8 minus 3, that will be 13 over 8. And this is what I need, x3. Yeah, sometimes he wants to continue the iterations until two successive approximation differ by less than 0.0001. Okay, let me do the calculation. What is f prime? It's ex plus 1. Yeah, I start with this one. Yeah, start with x equal minus 0.6. This is my x1. Why I choose this number? I think it's given in the question. Okay, yeah, in the MCQ, you cannot control the answers unless the first value will be given. Or you can think of it as a graph. What is, I need ex equal minus x. I mean, you can't think of it this way. I don't think you need this in the exams, but just for completeness. So I need ax equal minus x. So when the exponential function, this is the graph of the exponential function, intersect y equal minus x. Yeah, it's very clear it should be a negative value, and this value may be something near minus 1 somehow, not far from minus 1. So because of that, he started minus 0.6. You can start minus 0.5, minus 0.4, it's up to you. But since I know now, using the calculator, I'm getting these values. So I have x2 will be x1 minus f of x1 over f prime of x1. He did the calculation, he get what? Minus 0.56695. Okay, he did x3, he get what? Minus 0.56714. Okay, so this and this, they agree only in these 2 digits. The rest, they don't agree, so we cannot consider. So we consider this is correct. So x4 is minus 0.56714, where all of the 5s agree. So I'm getting this accuracy. Okay. Yeah. When, as in the first example, like in this one, I'm getting the values are going to the correct answer, or there is some kind of convergence. They call it convergence. So the numbers are going to a specific number. This is like in this. Yeah, maybe in this one also is more clear. Now I'm getting the digits are almost the same. The 5 digits are almost or are the same. So I'm going into a value. They call it converge. Okay. Now Newton's method doesn't mean that Newton's method will give me a convergence sequence or some values where it will converge to the correct answer. No, sometimes Newton's method will fail. Newton's method fails sometimes. One clear case, since the formula so if you get a value where f prime at xn equals 0, for sure this will give me a problem. So Newton's method will fail to converge on this. That's not only the case. There are other cases. For example, this one. This is a well-known case where what will happen, look at this. I have f of x equal x to the power 1 over 3. So what is f prime? It will be 1 over 3, x to the power minus 2 over 3. So if I want to get the formula, I say xn equal xn minus f of xn over f prime of xn. Do it as a calculation. I have xn minus, what is f of xn? It will be xn to the power 1 over 3 over 1 over 3 x to the power minus 2 over 3 xn. So this one as a power, I take it to the numerator. So that will be xn minus, will be x to the power 2 over 3 times x to the power 1 over 3, which is x. And this is also, it can be 3. So that will be minus 3xn. So actually this is give me minus 2xn. So assume I start with 0.2, or start with 0.1. Yeah, x1 0.1. What will be x2? Just multiply by minus 2. I'm getting minus 0.2. x3. Multiply by minus 2. I'm getting 0.4. x4 minus 0.8. I'm not converging. I mean, it seems it's not. I'm not going to the correct answer. x5 is equal to what? Is equal to minus 1.6. So it's they are increasing. I multiply by minus 2 every time. So for sure, the next iteration will not converge to the correct answer. And this is actually what happened. Start with x1. Yeah, the main idea, I need the intercept of the tangent line. So that will give me x2. Like x2 is going far than x. I know the answer is 0, but I'm trying to approximate that. x2, I'm getting x3. x3 is far from the correct answer than x1. x3 give me x4. x4 give me x5. So for sure this is will not converge. There is a formula the book is using where he says if the function satisfy this, then for sure I have a convergence for the Newton's method. Yeah, never had. I mean, I don't remember we have any question like that. But this is just for the information. Yeah, maybe sometimes they can be dealt with. There is an example in the book. Okay, let me go now. Before I go to the old exam questions, let us do this question. Approximate the square root of 3 to 3 decimal places. I don't have a function. What shall we do? But we notice if I write x equals square root of 3, then I can square it. So I have x squared equals 3. So I have this equation actually. X squared minus 3 equals 0. So this is the equation now. I can start with. So this is my equation. So my f of x, which I want to approximate is 0, is this one, x squared minus 3. I know the 0 of this is square root of 3. The positive 0. There is a negative 0, but I'm talking about the positive 0. So I will choose my starting point as the positive value. Okay, so this is my function. So I have the function x squared minus 3. F prime will be 2x. So I'm starting with, I know that square root of 3 is 1.7 something. So let's say, I said, okay, let me start 1.75. You can control the starting point. You can make it 1.6, 1.4, 1.5. It's up to you. But yeah, in the exam, it should be specified because any value will give you different answers. It will converge at the end if Newton's method converges at that case. So he plugged the numbers. He said x2 will be x1 minus f of x1 over f prime of x1. He did that. He get this 1.732. So they agree only in these two values, 1.7. We want 3 decimal places. So x3, he plugged the number. You get this number, 1.73200508, where they agree with 3 decimal places. So this will be a good answer. Okay, let me go to all the exams questions. If you use Newton's method to approximate the solution for this equation, I have the equation 2x minus 3 cosine x equals 0. He said start with x1 equal pi over 2. So this is what will be my f of x? 2x minus 3 cosine x. What is f prime of x? It will be 2 plus 3 sine x. Be careful. Yeah, derivative of cosine is minus sine. So 2 plus 3 sine x. Okay, so x2 will be x1 minus f of x1 over f prime of x1. I need x2 only. Oh, so I just plug the number. So x2 will be pi over 2 minus. What is f of x1? Yeah, I can do it here since it's, you need to be careful with the calculation. f of pi over 2, that will be 2 times pi over 2, which is pi. Cosine pi over 2 is 0, so it will be pi only. So that will be pi over f prime at pi over 2. That will be 2. Sine pi over 2 is 1. So I have plus 3. That will be 5. So pi over 5. So that make it over 10. I have 5 pi minus 2 pi, and that will be 3 pi over 10, which is this answer. So I think it's an easy things to do. Newton's method, yeah, it will be an easy things to follow. Just you need to remember the formula and plug the numbers. Yeah, so what is f of x here? X cubed minus 2x minus 5. I need f prime. So it will be f prime of x, 3x squared minus 2. I have x1. Yeah, as I said, he must give me x1. Otherwise, I cannot control the answer. x2 will be what? x1 minus f of x1 over f prime at x1. What is x1? 2. What is f of x1? Yeah, I have 8 minus 4 minus 5. 8 minus 9, that will be minus 1 over f prime at 2. I have 3 times 4, 12 minus 2, that will be over 10. So I have 2 plus 1 over 10, which is 2.1, since you wrote it as a digit. Okay. Now the same thing. I think we get the idea. We just follow the, so f prime will be what? 7x to the power 6 minus 6x to the power 5. So x2 will be x1 minus f of x1 over f prime at x1. x1 is 1. He gave me x1 is 1. f of 1 minus 1 minus 2. So it will be minus 2. The formula, it has a minus sign, okay? So this is minus 2 over f prime at 1, 7 minus 6, that is 1. So I have 1 plus 2, which is 3. So that will be the answer. Okay, I want to solve this equation. Starting with x1, he wants x2. Be careful. As we said before, Newton's method is used to approximate what? The zero of a function. So I need something equal 0. I cannot work out this. So my first step to make it equal 0. So either I move cosine or sine, yeah, make it equal to 0. So this is my function where I will apply Newton's method to. So it will be f prime. That will be cosine x. Yeah, I need to be careful here with the calculation. That will be what? Plus, yeah, plus sine 2x times 2, which is times 2. Am I right? Yeah. This is the derivative of cosine 2x. Okay, minus cosine, which is sine, the derivative. Okay, so x2 will be x1 minus f of x1 over f prime of x1. Sometimes when you feel the calculation needs to be careful, I mean, you need to be careful with the calculation, do it aside. F pi over 4 will be what? F pi over 4, because I need x1 is pi over 4. So I need f of x1 and f of pi over 4 and f prime of pi over 4. If pi over 4, it will be what? Sine pi over 4 is square root 2 over 2. Cosine pi over 2, pi over 4 times 2, which is cosine pi over 2, that is 0. So ignore it. So if so, square root of 2 minus 0 is just square root 2 over 2. F prime will be cosine, which is still square root 2 over 2. But here I have what? Plus 2. Cosine pi over 2 is 1. So that is plus 2. Okay. Now let me check this. F of pi over 4 over f prime of pi over 4. Yeah, you know what? Let me do the calculations right away. So I have what? Pi over 4 minus. Here I have square root 2 over 2. All over square root 2 over 2 plus 2. So I'm getting what? Pi over 4 minus square root 2 over 2 over, this is, I have common denominator, which is 2. So I have a square root of 2 plus 4 over 2. This is cancelled. So I have pi over 4 minus square root of 2 over square root of 2 plus 4, which is this answer. Yeah, calculation, need to be careful. Yeah, x1 equal 2. But be careful. First, what I need to do, I make it equal 0. So this is my function, because as I said, Newton's method, we use it to approximate the 0 of a function. So I need to think goes to equal to 0. So f prime, to find the 0 of this function, 3x squared, or to approximate it. So x1, he said equal to, so I have x2 will be x1 minus f of x1 over f prime of x1. x1 is what? 2. F of 2, 8 minus 8 gone. This is 1 over 2. 2 minus 2. And what I have f prime, it will be 12 minus 4. Yeah, 12, that will be 8. So I have 2 minus 1 over 4. 2 is 8 over 4 minus 1 over 4. That will be 7 over 4. So that will be my answer. Using this method to estimate the value of cubic root of x. So if I have x equal cubic root of 7, cubic, if I take power 3 for both sides, I have x cubed equals 7, because I need something equal 0. So that gives me x cubed minus 7 equals 0. So this is my f of x. F of x equal cube root x cubed minus 7. F prime will be 3x squared. So I started with x0, x1. These are just x0 equal 1. So x1 will be x0 minus f of x0 or f prime of x0. That give me what? 1 minus f of 1, 1 minus 7. That will be minus 6 over f prime. That will be 3. So I have 1 plus 2, which is 3. So that will be my answer. Yeah. He wants x3. He doesn't want x2. He wants x3. It means I will do 2 iterations. So this is my f of x. So f of x is x cubed minus 2x minus 1. F prime is 3x squared minus 2. Starting with x1 equal 1. What will be x2? Will be x1 minus f of x1 over f prime of x1. x1 is 1. F of 1, 1 minus 1, that is 0 minus 2. So it will be minus 2 over f prime, 3 minus 2, which is 1. So that will be 3. So x3 will be x2 minus f of x2 over f prime at x2. That gives me 3 minus f of 3. 27 minus 6 minus 1, that will be 20 over f prime, that will be 27 minus 5 minus 2, that will be 25. So I have 3 minus over 5, that will be 4 over 5. So it will be 15 minus 4, which is 11 over 5. So that will be my answer. Yeah, it's a matter of calculation. Yeah. Okay. Okay. The same thing, but now I need to make it like this, make it equal to 0. So this will be my function. So it will be, this is f of x. And what will be f prime of x? Yeah, 1 over 1 plus x squared minus 1 over 2 root x plus 1. He's starting with what? x1 equals 0. So x2 will be x1, yeah, minus f of x1 over f prime at x1. So that will be 0 minus f of 0. What is f of 0? Let me check it. Tan inverse of 0, 0 minus 1. So that is 1. Minus 1, I mean. F prime at 0, 1 over 1. That will be 1 minus half. Yeah, is it? Yeah, minus half. So it will be half. So I have minus 1 over half. That give me what? 0. This is minus 2 times minus plus 2. So that will be 2. And that will be the answer. Yeah, just a formula we just follow. Just approximate this. He won't give me x0, he want x2. He want 2 iterations. So f of x cubed minus x plus 1, f prime of x would be 3x squared minus 1. I have x0 equals 0. x1 will be x0 minus f of x0 over f prime of x0. x0 is 0. F of 0 it will be 1. F prime minus 1. So the answer is 1. So x2 will be x1 minus f of x1 over f prime of x1. Just doing the calculation. I'm not doing anything else. 1. This is 1 minus 1, 0 plus 1. So I have 1 over. I have plug 1 here. 3 minus 1, which is 2. 1 minus half, that will be half. That is really my answer. Yeah, I have this. He gave me x1. He wants x2. So my f of x is x to the power 7 plus 4. F prime is 7x to the power 6. So I have x1. x1, I have it minus 1. x2 will be what? x1 minus f of x1 over f prime of x1. So I have what? Minus 1 minus. Yeah, let me do f of minus 1. It will be minus 1 to the power 7, which is minus 1 plus 4. That is 3. But f prime at minus 1, that will be 7. So I have minus 1 minus 3 over 7. This is minus 7 over 7, so I have minus 10 over 7. This is the function. What will be f prime? It will be 2x minus 1. So if I have x0 equal 1, I want x2, so I want 2 iterations. x1 will be x0 minus f of x0 over f prime at x0. That will be 1 minus f of 1. 1 minus 1 is 0, minus 1 over f prime 2 minus 1, which is 1. So this is 2. So x2 will be x1 minus f of x1 over f prime of x1. x1 is what? 2. f of 2 is what? 4 minus 2 minus 1. That is 1 over f of 2. 4 minus 1, that's 1 over 3. That's 6 over 3 minus 1 over 3. That will be 5 over 3. Yeah. Using Newton's method with the initial guess, the approximate is 0 after 2 iterations. So I need x2 and x3. So this is the function. What will be f prime? 3x squared. Yeah, the numbers are complicated. It's okay. x1 equal 1. x2 will be x1 minus f of x1 over f prime at x1. That will be what? 1 minus f of x1. 1 minus 7, that's minus 6 over 3. Yeah, that gives me 1 plus 2, which is 3. That will be x2. x3, you want 2 iterations. x3 will be x2 minus f of x2 for f prime of x2. That will be 3 minus f of 3. 27 minus 7, that will be 20 over 27. Yeah, so you have what? 27 times 3, which is 81 minus 20, which is 61 over 27. So that will be my answer. Starting with this, x1, you want x2. I think we get the idea. Sometimes you need to be careful with the calculation. That's it. That will be 3x squared minus 2. So x2 will be x1 minus f of x1. You notice that I'm doing the calculation only. Huh? So that 2 minus f of 2, 8 minus 4 minus 5, that will be minus 1 over. I think we did something similar before. 3 times 2, that will be 12 minus 2 over 10. So it will be 2 plus 1 over 10, which is 2.10. That's it. Yeah. By using Newton's method to approximate the zeros of this function, he started with x1 equal half. Okay. Okay. So f of x is x cubed plus x minus 1. F prime will be 3x squared plus 1. I'm starting with x1 equal half. x2 will be what? x1 minus f of x1 over f prime of x1. Yeah, need to be careful with the calculation. Half minus. What is f at half? 1 over 8 plus half minus 1. So I can make it over 8. That give me what? 1 plus 4 minus 8, which is minus 3. Am I right? Yeah. Half is 4 over 8. And 1 is 8 over 8. So 1 plus 4 minus 8 minus 3 over 8. That will be this, minus 3 over 8. Over f prime at half. That will be 3 over 4 plus 1, 7 over 4. Okay, so that will be half minus or plus 3 over 8. Reciprocal of this, 4 over 7. That will be 1, that will be 2. Okay, so I'm getting half plus 3 over 14. So I have over 14. That will be 7 plus 3, which is 10 over 14. Divide by 2. That will be 5 over 7, which is this answer. So it's a matter of calculation. Yeah. The zeros of this. So my f of x is x cubed plus x minus 3. What will be f prime? 3x squared plus 1. I have x1 equal 1. So x2 will be x1 minus f of x1 over f prime of x1. That will be 1 minus f of 1. 1 plus 1, that will be minus 1. 2 minus 3. Here I have 3 plus 1 over 4. So I have 1 plus 1 over 4. 1 is 4 over 4, so that will be 5 over 4. That's it. I think we have 2 to go. Yeah, of 3. Okay. Using Newton's, you want to start with x1 and you want what? x3. Okay. So it means I need to do 2 iterations. So f of x, 2x squared minus 1, f prime will be 4x. Yeah, easy calculation. x1 equal half. What will be x2? Yeah, is equal x1 minus f of x1 over f prime of x1. So that will be half minus f of half, 2 over 4, which is half minus 1, that is minus half, over f prime of x1, f prime of half, 4 times that over 2. So that will be half plus 1 over 4. That will be 3 over 4. Okay. Hopefully I did not do a mistake in the calculation. That will be x2 minus f of x2 over f prime at x2. That will be 3 over 4 minus. Yeah, f of 3 over 4. That will be 2. 9 over 16 minus 1, which is 18 over 16, which is what? So f of 3 over 4. This will be 18 over 16 minus 16 over 16. That will be 2 over 16, which is 1 over 8. So that will be 1 over 8 over what? F prime over 3 over 4, that will be 3. Yeah. So I'm getting what? 3 over 4 minus 1 over 24. Now I take it over 24. So I need 6, 18 minus 1. So that will be 17 over 24, which is this one. Yeah, just calculations. Nothing to worry about. Yeah. This is f of x. And you want what? F prime. I need f prime to do the calculation. So it's 1 minus times minus plus ES minus X. He started with X1 equals 0. He wants X2. Will be X1 minus f of X1 over f prime of X1. That will be 0 minus. What is f of 0? 1 minus 1. Yeah. Is it? It will be f of 0, 0 minus e to the power 0, which is minus 1 over f prime. It will be 1 plus 1, 2. So I'm getting half. Yeah. Yeah, this is just a statement, true or false statement. Yeah, forget about this. They're not related to Newton's method. This is the statement which is related to Newton's method. It said Newton's method fails with the initial guess, which is true. With the initial guess corresponding to a horizontal tangent line. When we have a horizontal tangent line, when we have f prime of x1 is equal to 0. So if there is f prime, then Newton's method for sure it will fail, because I have over f prime at xn. So there is a problem here. So for sure Newton's method will fail. So this is the true statement. Yeah. Let me stop the recording. This is the end of 3.8. So let me stop the recording. I think it's an easy section where you can do it easily. Thank you.